All right, so today we're looking at the homework assignment for 2.7, which is kind of short. She's also the very end of Unit 2, which means we get to have a test pretty soon. So you have that coming. So it's, it's nice to be done with 2, but that means there's a test. Anyways, I'm going to do the second one. It's probably the hardest one. You don't have to do all the work in number 1 that I'm doing in number 2. You just have to graph. So let's go ahead and solve this. It says solve for y, convert it to vertex form. So I would isolate the 2y by moving the 3x squared over, and then I would divide everything by 2. So here is my equation, and I don't need to put that in vertex form. That's easy to graph. It goes up 2 right there, and this is the initial slope. And it's not fall 3, run 2. You can only do that in one block. It's kind of weird. Like, how do you fall 3/2 of a unit? Oh, well, you can fall 3/2 of a unit as you move right and left. You have to be done one movement right, one movement left. So if I fall 3/2 and move right, I'd be about right there. Fall 3/2 and move left, I'd be about right there. And that's that one. Everybody ought to be able to graph that. That has a y-intercept at -1, but I know there's several juniors who just, God love you, can't. It has a slope of -1. So we're going to have a y-intercept right here, and we're going to fall 1 and run 1. And we're going to graph it. Now it says determine the number of the solutions. There's one there, there's one there. It has 2 solutions. That's all it says. It doesn't say answer the question. It doesn't say what are they. It says determine the number. Nothing more. All right, we got some substitution going on. 4 looks like it might be decent. You're supposed to solve using substitution. So the first thing you're going to do is probably just isolate y. And we're going to take that and we're going to put that right there. That's substitution. Y is 19x plus 22. Wherever I see that, that's what I get to be. 19x plus 22 is 3x squared plus 7x minus 10. I'm going to shift everything right because I want to use a zero product property. I am shifting right so I can use the zero product property. 7x minus 19x is negative 12x. I know that throws some kids off that I don't show that, but I'm not supposed to show that. Negative 10 minus 22 is negative 32. Now, I have no idea if this factors or not. I'm actually going to do it on a separate piece of paper, see if it does. Factors 32, probably 8 and 4. That's not going to work though, is it? Nope. 2 and 16. Nope. Am I missing anything? 8, 4. I don't believe it factors. I'm also very tired. So here's what I'm going to do. I'm going to pick out A, I'm going to pick out B, and I'm going to pick out C. Then I'm going to sing a little song. Does x equals negative b plus or minus square root b squared minus 4ac all over 2a. We'll find out if it factors or not. If it factors, the quadratic formula will tell me it factors because it'll give me some numbers. All right? Just looking at it, I don't think it does. All right, so I picked everything out. Opposite of b is a positive 12. If you're going to square something, drop the negative. It's going to be positive anyways. Minus 4 times a, which is 3, times c, which is negative 32. All sitting pretty over twice a 3. Let's just plug it into the quadratic formula. Now we're going to clean it up. Now what do we have in here? We have a negative number, don't we? Well, that's just interesting. So we're going to have imaginary solutions, and we're going to figure out what they are. It doesn't have any real solutions. We're going to find them out. No, it doesn't. That's 1232. That's too big for me. $528. Turns out it doesn't factor. How do I know it doesn't factor? It's because there's no square root of 528. So I'm going to play with a radical here. She is divisible by 4. Something else I can take the square root of is 16. She's divisible by 16. Turns out 528 is 33 times 16. That's as far as I can take it. But x is 12 plus or minus the square root of 16 times 33. And both those pieces are sitting over a 6. 12 over 6 is 2. The root of 16 is 4. And 4, 6 reduces down. So I am 2 plus 2/3 of root 33, or I'm 2 minus 2/3 of root 33. And it doesn't actually matter here, but I want you to pay attention that these are conjugates. Those are your answers. They've got some funny looking answers. And you are solving. So here's the fun part. That's x. All right. Now we get to find y. And we have this little equation here that y is 19x plus 22. So I'm just going to plug that in. Everywhere I see an x, I am a 2 plus 2/3 root 3. And then I add 22. It's kind of funny. 19 times 2 is 38. I've got that 22 I can work with. I'm going to put it right there. And when I do 19 times 2 over 3, I get 38 over 3 root 3. And if I put 38 and 22 together, what do I get? 60. So 60 plus 38 thirds a root of 3. So here's a funky ordered pair. I have an ordered pair 2 plus 2/3 root 3, and then 60 plus 38 thirds root 3. What a funky looking answer that is. Most teachers just teach decimals on this. They do. All right, the other one happens when you plug in the 2 minus. So y is 19 times 2 minus 2/3 root 3 plus 22. And you're still going to have the 38 and 22, which makes it 60. But here you're going to have a minus 38 over 3 root 3. So there's the other y value. If you plug in 2 minus 2/3 root 3, you get back 60 minus 38 thirds root 3. What an ugly little problem that is. But those are the intersections in perfect non-rounded form. Hideous, isn't it? All right, I'll do 6. Y plus 5 is a half x. So y is 1/2 x minus 5. So this should say y equals. It doesn't. I need to go back and fix that. So 1/2 x minus 5 is 3x squared minus 2x plus 7. I'm going to do something silly here. I'm going to double both sides. As long as you do the same thing to both sides, you don't break equality. And that's going to give me x minus 10 equals 6x squared minus 4x plus 14. The reason I doubled both sides is because I didn't want to screw around with fractions. Plain and simple. Didn't want to mess with them. So I don't. Now I'm going to shift everything over to the right. So I have 0 on the left and my x squared stay positive. Negative 4x minus x is negative 5x. And 14 plus 10 is 24. And I don't have a lot of writing room here, so I'm going to think about if this factors. My gut says use 3x and 2x. And factors of 24 are going to be 6 and 4. Probably. That don't work. Okay. Maybe 3 and 8. What I did, and you couldn't see it, is I was doing a bunch of guess and check. Nothing was working. I don't think it factors. So I get to use my good old friend, the quadratic formula. A is 6, B is -5, C is 24. And I just crank it out. Formula's up here. That's what I'm plugging into. So x equals -b, which is 5, plus or minus square root of 5 squared minus 4 times 6 times 24. Oh, here's why. It doesn't have any answers. If I plug those numbers in, assuming I made no mistakes, and I don't feel that I did, I'm going to get imaginary numbers. So x is going to be 5 plus or minus. We have a 25 minus something else there. 24 times 24, which is what, 496? Now, we got 5 squared minus 4 times 6 times 24. -551. Sitting over 12. So, I know that this is imaginary. There are no solutions. And again, that's assuming I didn't make a mistake. If I made a mistake, feel free to correct me. It does not bother me to be corrected. I'm not one of those teachers who's going to lose their crap. Unless you're wrong. Alright. This says solve your system by shading. You are supposed to use your calculator to find the vertex and the intersections and clearly label them. It's actually not going to be too bad. It's really not. I'll do 8 since it's the hard one. The first thing you're going to have to do on 8 is you're going to have to move this guy over here. So that says x minus 5 is less than y. And you might want to think about that saying y is greater than x minus 5. All right? We're going to use our calculator to draw this thing. And this one's fun. So one of my equations is x minus 5. The other one is negative 3x to the second plus 6x plus 1. Zoom 6. Turn that contrast down so you can see it. There we go. Now you can see it. And here's what she looks like. Now, I don't know if you need a calculator to graph this or not. But that crosses at -5 right there. And she runs 1 and rises 1 and runs 1. So if she rose 5 and ran 5, she'd pass right through there. And notice the equation is to be greater than. You'd be shading above it. Then you have your parabola. Your parabola has a y-intercept at 1. I don't know if you remember that. ax squared plus bx plus c. This is your y-intercept. She has a y-intercept at 1. She has a vertex using that maximum function. Left, right, guess at 1, 4. And let's find where she intersects the line. Second trace 5, intersect. Get close, press enter, enter, enter. Intersection, whenever she crosses this line, somewhere over here, is at negative 0.808, negative 5.808. Second trace 5, get the other intersection, enter, enter, enter. And that one's at 2.475. Negative 2.525. And remember, the line wanted me to shade above. That is a less than symbol. It's saying shade below. Here is your solution space. That's your solution space. Your solution space happens. Have solutions so long as x is stuck between negative 8.08 and 2.475. If you like intervals, it's supposed to be a 0.8 right there. 0.808, comma, 2.475. Take a break, and I'll be right back. I just got really tired for some reason, so I need a break. All right, I'm back. I know you guys don't appreciate this, but they removed trigonometry from your Algebra 2 standards, but it's still on the ACT. And this is a typical ACT question. An angle is drawn with the initial side being the positive x-axis. So whenever you draw your angle, it starts here. Try and bold that as best I can. And its terminal side intersects at negative 3, negative 7. So the angle rotates down to here. That's the actual angle. I haven't decided what I'm going to teach y'all after we're done with the class, after you take your big test in April. It might be trigonometry. It's going to be something, because I still feel kids should learn trig, even if they don't want to learn trig. But anyways, you intersect at negative 3, negative 7. Now let's talk about this triangle. You may not see it, but I could just triangle this out. I could make it a right triangle. It went back 3 and down 7. And I'm not saying there is a triangle out there that possesses negative length, because it wasn't actually there in the first place. I'm just saying I could draw a triangle, and those would be the units on it. Now, if I do Pythagorean theorem, I'll get the hypotenuse. And if you're going to square a negative, you may as well make it positive. 3 squared is 9, 7 squared is 49. You put them together, you get 58. So that means your hypotenuse is the root of 58, which, as far as I know, does not simplify. Yes, it does. It's divisible by 4. It's 4 times 17, which is 2 root 17. Hypotenuses are always positive. Now, I asked for the 6 trig ratios. These are on your form quizzes. You start with SOHCAHTOA. Sine of an angle is opposite over hypotenuse. Cosine of an angle is adjacent over hypotenuse. That comes from SOHCAHTOA. Put the dots together. The tangent of an angle is opposite over adjacent. So when you do these, your angle is right there with the x-axis. That's what you're going to look at. So sine would be opposite over hypotenuse, which is negative 7 over 2 root 17. And I know there's a couple of you who will be like, I never heard anybody do this stuff before. To clean this number up, because you're not supposed to have a radical in the denominator, multiply top and bottom by root 17 over root 17. That becomes negative 7 root 17. Root 17 times root 17 is 17 times 2 is 34. That's the sine ratio. Fair enough. Cosine would be adjacent, which is -3 over the hypotenuse to root 17. And you clean it up the same way you did the other one. Multiply top and bottom by root 17. And you get -3 root 17 sitting over 34, which also doesn't simplify any more. Tangent ratio is opposite over adjacent. That's -7 over 3, -3, which is +7/3. Now the other three ratios are reciprocals. The reciprocal of sine is called cosecant. Sine says O, cosecant is a ho. Now notice their reciprocals. Flip this thing. 2 root 17 over 7, negative goes in the numerator. Cosine is it's a breath of fresh air. Its reciprocal, secant, is a funny guy. Ha. And all you do is you flip. So -2 root 17 over +3. Negative symbols are supposed to be expressed in front of the fraction or in the numerator. And the reciprocal of tangent is called cotangent. And tangent says OA, cotangent says AO. Anyways, just reciprocate. It's 3/7. And that's 10. Now you can do 9. And this is not an Algebra 2 skill. Not Algebra 2. It's geometry, which you passed. So what's the problem? I'm going to do 2 more of these. It says you can do any 4 by factoring and any 2 using the quadratic formula. Every one of them factors, but I want you to do 4 of them factored, 2 of them with the quadratic formula. I'm going to do 1 of each. But I know they all factor. So I'm going to do 18, and I'm going to factor it because there's not a whole lot of room. What I'm going to do is I'm going to shift everything left. So 42 minus 7 is 35x squared. Negative 69x is going to stay there. And 20 plus 8 is 28. And that's what I have. And then I'm going to guess, and I'm going to check. Plain and simple. But I know she factors. To make a 35, I would use a 7x and a 5x. And to make a 28, my gut would say 8 and 4. Not 8 and 4. 7 and 4. And that works. Because the outside makes 49. And the inside makes 20. If I make them both negative, I get the center term. So minus, minus, still equal to 0. Use the cover-up technique. Use the zero product property. 7x minus 4 is 0, which means that x is 4/7. Or 5x minus 7 is 0, which means that x is 7/5. So I did that one by factoring. Next thing I'll do is I'll do the quadratic formula, and I'm just going to pick on 16. 16, I will use the QF. First, you put it in STD form. And that would become 28n squared plus 184n plus 96 is equal to 0. And I can make the numbers quite a bit smaller, I think. I can pull at least a 4. That makes the numbers quite a bit smaller. And there's nothing else you can pull from it. But A is now 7, B is now 46, and C is 24. And by the way, it would factor. These do factor. They all factor. I'm going to get nice answers out of the quadratic formula. So again, goes x equals -b plus or minus square root b squared minus 4ac all over 2a. I just plug stuff in. So opposite of a positive 46 is a negative 46. Plus or minus the square root of a 46 that is squared. Minus 4 times 7 times 24. All sitting over twice as 7. Anyways, where was I? What's in that radical? I bet it's something that works out. 46 squared minus 4 times 7 times 24. 1444. Has a square root too. It's 38. So it's negative 46 plus or minus 38 over 14. I'm going to branch off and do the work. Negative 48 plus 38 is negative 10, sitting over 14, which is negative 5/7. Negative 48 minus 38 is negative 84, I think. Negative 86. Yeah. Negative 86 over 14, which reduces on down. Negative 43 over 7. I just don't trust myself today. No, I should. And there's your solutions. It would have been a funny looking thing to factor, but it would have factored. It actually would have factored as 7x minus plus 43 and 7x plus 5. I don't know if you can make that jump or not. But that is how it would have factored. Maybe not. I don't know. Too tired. That's what she is. There you go. So you have 1, 2, 3, 4, 5, 6, 7, 8, 9 problems to do. I did half your homework. I want you to take note of that. I did 1/2 of your homework. And yet I'm the problem. I don't think so.